This is Joris Peels, and we're here with another episode of the Prosthetics and Orthotics Podcast. And, if you're new to us, what we're essentially doing is, I'm a 3D printing consultant, all about 3D printing, and I'm very interested in the digitization of orthotics and prosthetics. You know, is it going to be similar to dental, where every office or every user in the space is going to be at least doing something in the digitization sphere? Are we going to 3D print all of the orthotics, or is it just going to be very limited? Is this really going to change the lives of a lot of people who wear prosthetics and make them more comfortable, or is it just a flash in the pan? And the person helping me with this is Brent Wright. And Brent Wright is one of the people on the forefront of, he's an orthotist and prosthetist, and he's one of the people on the forefront of actually digitizing this stuff. So welcome, Brent.
Oh, man, it's so good to be here with you, and I can't tell you how excited I am about who we've got on the podcast today.
Okay. Well, first, Brent, you came back from the jungle of Guatemala, quite literally.
Yeah, absolutely. I actually, over the course of 6 days, saw 26 patients, and have a good little team. And we've got we're investing in some local talent there in the jungle of Guatemala, who has been taking great care of patients over this period of time of COVID when travel's been difficult. And I'm really excited, and this digital process ties right into what we're doing. So I was able to actually deliver a scanner to him, and so we're gonna be emailing files back and forth, 3D printing and sending stuff down for him to fit. And I'm really excited about kind of this next chapter in the jungle of Guatemala.
Okay, that's good, dude. That's really good. That sounds really good. So, and who do we have with us today? Who is going to...
So today we have Sagar Shetty, and he is a certified orthotist and prosthetist. We've connected. We've been connected for a long time. Wouldn't you say, Sagar?
Yes, we have.
Yeah, so we connected over 3D printing, specifically FDM-style 3D printing. But what's also neat is Sagar's very humble in what he does, but he's the clinical director, director of clinical operations with Bionic Prosthetics and Orthotics Group, and they're headquartered in Maryville, Indiana, and they have clinics across the country. He's been in the field a long time, seen really the transition from traditional fabrication to digital fabrication. You know, P-Light liners. He's probably made plenty of P-Light liners in his day to gel liners. And so, you know, this technical change, it's neat because he has a historical perspective. He's just not parachuting in right now. So I'm super excited to have him. He loves 3D printing, and he's a great ambassador for the field.
Yeah, welcome.
Thank you for having me.
So first off, is 3D printing, is it just like a side dish in your practice? Is the main flavor? How does it work with you?
Well, at this point, it is the main flavor at our practice and everything we do. You know, it wasn't the case until a few years ago. Practitioners in ONP are set in their ways, and this has always worked, to sell the concept of advanced technology, to sell the concept of, hey, you don't have to take a cast, you can scan, you can digitally modify, and you can print and fit the socket. That concept was very hard for ONP practitioners to kind of come to terms with. But 3D printing in terms of technology, in terms of materials, have come a long way from where it was even 4 or 5 years ago. So at this point, it is our main flavor. We use 3D printing for providing ONP care at our clinics every day.
Mm-hmm. And what was your first involvement in 3D printing? How did you first get in touch with the technology?
We first got involved with 3D printing just because we were mesmerized with the idea of, a printer printing a socket. And, Brent has talked about it, multiple times in the past about how people get excited and mesmerized with newer technology and they just jump into it, not knowing all the elements that go into making that work. There are so many factors. There's the hardware, there's the software, there's the understanding and learning of the digitization of the processes. And we were one of those people that jumped into it about 6-7 years ago. When there was a 3D printer introduced in the world of ONP, we went and bought the machine right away, and we were so excited, but knew nothing about, the CAD part of it, knew nothing about digital modifications or how to design a socket. We just were like, okay, we bought a printer, now it's going to print sockets for us. And that's not how it works. And, there's a big learning curve there. And also back then, printers were not as advanced, at least for ONP applications, or we didn't have access to that level of advancement. In terms of what the printer can do, how fast a printer can print, what materials it can print, how strong it can print. So that's kind of where our journey started about 6 or 7 years ago. And after a while, I realized that just having a printer in the office is not good enough if I don't know how to use it. So I think it was in January of 2019, I actually put effort into learning, 3D scanning, 3D design, digital modifications, how to design a socket, what materials to use, stuff like that. And that's when we kind of started to see, okay, now we understand how the process works, and we started printing. I remember when we printed our first 3D printed socket, it took about 70 hours to print the socket on a very small, simple FDM printer. Every day in the morning I would come to the office and the printer would still be running, and I'd be like, okay, a couple more inches to go, and then I would come back the next day, okay, it's still printing, one day the socket will be ready. And when it was done, I was the happiest person on earth, because I was successfully able to print a socket, even though it took 70 hours. Of course, it was hard for me to sell the idea to all my coworkers and other practitioners, because they're like, 70 hours for one socket, it's never going to be fast enough. It's never going to be strong enough. But from there, we have come a long way. Now I have multiple printers at our lab, and I have a technician dedicated just to running the 3D printing side of the lab. And now we are able to print a prosthetic socket in an hour on the printer. So from 70 hours for a socket to 1 hour for a socket, it's been a fun journey.
And what's that difference due to? Is it what made that big difference?
Well, the difference, multiple factors. One is the material. The printer itself plays a big role. Right now we have a high flow extrusion system on our printer. So we use the Dice Design Typhoon extruder. That's a high flow system on a Filament Innovations Kratos printer.
I love Dice Design. I'm a huge Dice Design fan. I think they're incredible.
Yes, it's a beast. It has a 2.5 millimeter nozzle that extrudes a lot of material really, really fast. And we are able to print a 3 to 4 millimeter or 5 millimeter, even up to 7 millimeter wall thickness socket, really quickly. So because it doesn't have to do multiple passes and doesn't have to do infills, it just extrudes, a whole lot of filament really fast, and that's what allows us to print the sockets at the speed that we are.
And what filament are you using, or do you tend to use the same?
We use different filaments. So for our test sockets, we use PETG. PETG is a material that traditionally has been used for diagnostic sockets in the field of ONP for the longest time, just in a sheet form. And that was one of the things I was very interested in. How do I use materials that the ONP professionals are already familiar with? So PETG was an easy pick because people know what PETG is like on a traditional test sockets, how it behaves, how brittle it is. So we use PETG in filament form instead of sheet form, and so that works for test sockets. And that's where we initially started. We just wanted to see if we can just do test sockets on those. But over time, we have played with multiple different filaments. Now we print flexible inners and prosthetic covers using TPU. We use copoly, a copoly blend to make preparatory sockets. We are also using polycarbonate and playing with multiple different materials.
Okay, that's interesting. And do you use anything really flexible, really soft, or you don't really? That's not really.
Yeah, so when it comes to flexible, as you know, flexible materials are very hard to print on FDM printers. But after playing with different materials, we, currently we use TPU. I use TPU from Matter Hackers to print our flexibles, and I have had no issues with it printing just perfectly on our high flow system. So we do flexible inner sockets and BK covers. Using TPU. We are playing with, other materials as well. There are, now a lot of different foaming TPUs and foaming PLAs, with, different shore hardnesses out there. So we have been playing with those as well.
Yeah, also maybe a little bit more about the printer. I mean, I think not a lot of people may be familiar with Filament Innovations. I mean, I know that there's this crazy guy on my LinkedIn called Michael Gorski, and he does all these insane things. He has something that looks like a very industrial machine, let's say. And so how did you end up getting it, and are you happy with it? Or
Yes, very happy with it. Actually, Brent is the one who introduced me to Mike, who owns Filament Innovations. And when I first met him, he did not have a high flow printer system. So he had a standard flow printer, and he used to build it in his garage. But very reliable guy, very reliable machines. My first machine I bought from him was in 2019, and it was a standard flow Icarus model. And that machine is really what gave me the kickstart into, okay, this is feasible. We can do it, because it had a large build area. I would design 3-4 sockets at a time and throw it into the printer at the same time. And it would use standard flow, technique, and it would print overnight. In the morning, I would come back and 3 sockets are ready. So on average, it would take anywhere between 6 to 8 hours per socket. So if I threw 3 sockets into it at the same time, because it had the build area to print 3 or 4 together, it would take anywhere between 20 to 30 hours to print them all. But it would once I hit print, I wouldn't have to worry about it. It would keep printing. So that's kind of where we started, and I used that printer for about, well, I still use it, but after using it successfully every day at our practice for almost 2 years, he came back. He said, "Well, we are working with Dice Design on this new extruder, and this can print stuff really fast." And when I saw the quality of what it was able to print, and how it's not just about how fast it can print, but is it feasible in ONP? Is it strong enough? Can we put it on a patient? Can the patient tolerate the quality of the print? And I was amazed at the results, at the initial results, when he came up with the high flow system, with the Typhoon extruder with Dice Design. And now I think I have 4 of his high flow printers in addition to the standard flow printers. And all of those printers are running all day long at our clinics. Now, initially, we started with having those printers in just our central fabrication facility, where, the practitioners from, we have 33 clinics in 9 different states. So, we have practitioners everywhere spread across. And, what we did is we gave all our practitioners an iPad and a structure scanner and said, you can take a scan or you can take measurements. You send it to our lab and we will modify it, design it, print it, and ship it to you. And that worked with the first, 2 printers here. But now they want, they like it so much, they're using it so much, they're like, well, we want to do this quicker. We don't even want to wait for shipping. And so what we started doing now is we are putting these printers at the local clinics. And so when we receive the scan, we digitize it, we design the socket, and we manage the printers from here, from the lab. So my technician from here accesses the printer at a facility far away from here and just prints it on that printer. So what the clinicians do is, patient comes in, they take a scan, and say, go grab breakfast or something and come back. And by the time they come back, the printer is printing the socket. And we have put some of these printers in the lobby, in the waiting area, so patients can actually sit there and watch their own sockets being printed. And it's a great way to engage the patients in their care. When they're watching the process of how their prosthesis is being built, and it's a lot of fun. Patients enjoy watching that process, and so that's kind of what we are starting to do now.
Sagar, how has the adoption been for your clinicians? Has it been a tough road? And I know you guys are acquiring some businesses, so don't get all in deep, but just maybe say some of the hurdles, some of the positives, and negatives. We love honesty too, but and we know there's challenges along with it. But I mean, you grow into 33 clinics, and I know you've got a myriad of clinicians. That's pretty awesome, man.
It is. Thank you. No, we have been very lucky. We have some amazing practitioners at our practice. Certainly when we first started, introducing the idea of, digitizing this whole process, there was a lot of resistance. There was a lot of, hesitation, because, and understandably, because, it's not something that they are used to. It's not something they have seen, touched, felt. And, my goal was, I want to be respectful of their skills, of their comfort level, and introduce it to them in phases or stages, at the level that they are comfortable with. So there were some practitioners who were like, oh, I don't want to deal with taking a cast and making a plaster model and getting my hands dirty and going to the lab. And so I will take a scan and I will send the scan. And I created the platform where the practitioner could choose at what level they want to digitize their practice in their clinic. So some practitioners would just send a scan, a raw scan of the patient's limb with the liner on, and we would modify it, design it here, print it, send it to them. Some practitioners said, well, we like to do our own modifications even if I take a scan. So we allowed them to take a scan. We provided them access to digital modifications remotely so they could do their own modifications, and then we just designed and printed the socket for them. Some of them were like, well, I like to take a cast. I don't like the idea of a scan because I need, I do my modifications while I take a cast, which I can respect. So some clinicians would take a cast and then they would scan the cast and send us the scan of the cast, and then we would just, modify accordingly. So what I did is, because we have a lot of young practitioners and a lot of seasoned practitioners at our practice, I talked to each practitioner and said, okay, what's your comfort level? Are you comfortable taking a scan? Or do you just want to take a cast? Do you only want to do test sockets? Do you want to play with flexible inners? Do you want to do BK covers? And kind of just introduce it to them slowly, one stage at a time. And what I've seen is that approach was very successful, because when I was respectful of their comfort level and kind of just slowly introduced the idea to them, and when they started using it, they started getting more and more comfortable with the idea. Also, when you first print something, for their patient, and they actually are able to touch it, feel it, see how strong it is, put it on their patient, see it working. I see this bulb glowing in their head. Okay, wow, this works. Yesterday, we just put a brand new printer at our clinic in Cincinnati, and I was just remotely helping the technician just plug it and just set it, and the practitioner was like, well, I just saw a patient an hour ago, and I have measurements for an above knee socket. Do you think we can print it on this printer now? I'm like, sure, why not? And this is a practitioner who's never used, 3D printing at her practice. And I said, well, send me the measurements. We'll design it. We'll print it right now for you. And she couldn't believe it. She texted me the measurements. In 15 minutes, the modifications were done. The file was ready to print, and I hit print from here and started printing on a printer there. An hour and a half later, she had the socket, and she said, "I cannot believe this. I just saw this patient 2 hours ago, and I have a socket in my hand." Nice. So yes, there have been challenges. The initial challenge was the time that it takes. I mean, if it takes 40 hours, 70 hours to print one socket, well, my technician, can make it in 4 hours if I just give him a cast. That was a common argument that I would hear, that 40 hours and 70 hours for a socket was not acceptable to anybody. Then when we figured that out and we're like, okay, now we can print it in 6 hours or 8 hours or 10 hours, they're like, well, but is it strong enough? Can my patient actually walk on it? Is it going to crack? Is it going to break? And, I would be lying if I said, every socket we have printed has been strong. No, we went through that learning curve. We played with different materials, and, strength certainly was an issue, but we learned, we adapted, we played with different materials, settings, and now we are able to show them that, hey, this is strong enough. We can actually have the patient walk. We have pictures, we have videos. We kind of created a clinical group where all the clinicians kind of share what they're doing and how their patients are using these sockets. So that also helped.
I think it's interesting that a lot of people they're always, especially with new processes, let's standardize it. So everybody does it in the same way, and everybody does it in the same way with the same training, everything. And you didn't do that. You actually approached everyone individually. And you did lots of different things for them, and that led to. I think it's really important. People are always just talking about we couldn't implement 3D printing, or it's difficult to implement 3D printing, but you did it from your employees' point of view, and I think that's a really wonderful thing to do.
Sure. Yeah. And because strength has been a topic of discussion. Anywhere we go, anywhere we talk to practitioners, not just our practitioners, but in the industry. Everybody has that concern. Hey, but is this strong enough? Has it been tested? Mm-hmm. And, the interesting thing is, and Brent can throw some light on it as well. But, I always ask them, well, what kind of studies do you have accessible to you that qualifies the strength of the traditionally fabricated test socket or a traditionally fabricated laminated socket? There are no studies that that say, well, it should be this strong. The only standard that I am aware of was the ISO was 10328 was the standard that was initially set for prosthetic components. And any studies that have been done on the strength of sockets, they have used that ISO standard as the benchmark. But that ISO standard wasn't necessarily created for sockets, but that is the only benchmark we have. And we realized that it would be nice to have objective data to show is this strong enough? Because that's one of the factors where practitioners will feel comfortable using these things on their patients at their practice, if they know that it is backed by data that, okay, this can print something strong enough. So what we did is we are involved with a lot of research and work with different universities on research grants and stuff like that. So we are currently doing a DoD grant research on the strength of 3D printed sockets as compared to traditionally fabricated sockets. We are almost done with the study, not quite there yet. The initial phases of testing are done, and we are very excited about it. What we did is we fabricated a traditional test socket, we fabricated a traditional laminated socket, and we fabricated 3 different types of 3D printed sockets, all of DM. Just different materials, and now we are studying the strength, durability of all these sockets against each other and against the ISO standards, so that we can have more data to back up the strength and the feasibility of 3D printing in O&P.
I think that's a really great initiative. I think there should be a lot more people looking into this. I mean, a lot of people always complaining about what there isn't there, but it's not. But there isn't. But it's nice to see you guys like just trying to make more of what people need. I think that's really good. I think one other thing I noticed. So first you had a centralized lab. Now you're spreading out. Where do you want to head to in the future? Are you still going to do this method of like controlled from a centralized lab, but placed at local centers? How do you?
No, I think my goal is to give the clinicians and the clinics the independence that they need. The ultimate goal is how do we provide efficient, quality patient care at our clinics in the most in the fastest manner possible. And down the line, the goal would be that the clinics have their own printer, and patients come in and they're scanned. The socket is printed right there, at least the test socket phase. Of course, there's, I think we have some ways to go until an entire socket, can be a definitive, prosthesis for them to take. We have reached a phase where we are able to print with materials that allows for preparatory socket use that we have had patients, take home and use for several weeks up to a couple months. And we have had no issues with them, breaking those sockets. So we are at a stage where we can comfortably say that we can print a preparatory socket that the patient can take home with their prosthesis in the initial stages. But we are working with different materials that could lead to definitive sockets. Now, when we talk about definitive sockets, 3D printing certainly is capable of making definitive sockets with other technologies that are available. And Brent works with a lot of MJF technology, and with MJF, Brent does an amazing job of creating a lot of definitive sockets out there, and if we have seen a lot of his work, so it's certainly out there. My focus has been more on the FDM side of things, and the reason for that was, FDM is more accessible and more affordable as a technology to invest in. Or the printers itself are relatively less expensive than MJF or SLS technologies. And, I come from India. I was born and raised in India. I went to ONP school in India, and I worked there for several years before I moved here. My interest in FDM and in 3D printing is long term. The goal is how do we make this technology accessible and affordable to people across the globe, in countries where there is limited access to technology, and that's kind of where my motivation has been, working on 3D printing and different materials. Is if people are not taking cash, if we can take a scan and we can print anywhere and at an affordable cost on an affordable printer, that is durable, that is usable. That's my ultimate goal, to make it more and more accessible to a larger population.
Okay, that's really good. But just like I think that sounds really nice, but also it's like the problems that you're going to get are going to be very prosaic. Let's say very kind of simple. Like for example, how are you maintaining your printers in different locations at the same time? How do you even do something simple like that? How do you make sure everything has the same settings and things like this?
Right. And we are learning through experimentation. Like I said, we have had printers here that my technician was maintaining and troubleshooting and printing. But now that we have started putting printers at different locations, certainly, we will have a learning curve there as well. We will have to learn, okay, how do we train someone locally to maintain that printer on a regular basis? Somebody at the local clinics, maybe it's the clinician there, maybe it's a technician there, somebody who can learn to operate and maintain the printer. Settings for the printer is easy. I mean, once you figure out the settings, you can just load it on the slicer, and I mean that's easily copy paste. Once you have figured that out. But yes, we foresee some challenges in implementation. Right now the printer is maybe at a local clinic close by, but what if we put a printer overseas? Like Brent, goes to Guatemala and does a lot of amazing work there. We have participated in some outreach work ourselves where our practitioners go overseas and see a whole bunch of patients and come back. We also have some clinics overseas. We have about 10 clinics in India as well, through which we also do some outreach work. And, I'm at the initial stages of exploring how can we bring this technology there and make it more affordable. I mean, at the current time, till they get used to it, I mean, should we print stuff here and send it? Is it going to be economically feasible to do that? Or would it make more sense to have a printer somewhere locally at a camp where we do outreach work, where they can print themselves and maybe train somebody locally there? I mean, I can foresee a lot of technical and logistical challenges with that, but you won't know until you try.
Yeah, and do you think? I think like one of the things I've seen go horribly wrong is that people try to then, with a Western perspective, if you will design something that is different than the one we use for like the overseas place, you know what I mean?
Right. The advantage I have in that area is I have worked overseas. I've worked at local facilities, and at least in India, and where. Yes, I mean, the way they design the socket, the way they print, the components that they use, there are subtle variations in how O&P care is delivered in different parts of the world. And being able to understand that and adapt to that, to their needs. And then, again, it's the same approach. Not everybody fits in the same mold. Just like we did it here with our clinicians. If we do go overseas, if we do outreach camps, we have to be able to listen to the patients and the practitioners there and see, what their needs are. In a lot of those places, people don't use gel liners because of either the temperature and the recurring costs that are involved with gel liners. A lot of those people use skin fit sockets with just, a ply fit. So how do we then modify this technology where, we can have a surface structure that is smooth enough for them to be able to use it without a gel liner? So I'm excited about the possibilities of what we can do.
Mm-hmm. Sagar, I wanted to just pivot on this idea of high flow. I mean, going from 70 minutes to 1 hour is just incredible. What are some of the challenges that you've had as far as I think we talk about accuracy, dimensional accuracy, and maybe too much in the prosthetic realm. When I say, hey, we could be plus or minus 1 millimeter and still be in the ballpark, or you can throw a sock on, what are you seeing when you've gone from, say, the standard flow to the high flow, and what are some things to look for people that aren't familiar with some of the high flow?
Sure. So, with high flow, because it is extruding so much, it's melting and extruding so much material so fast. It's hard to print something that is what's the right term for it? Precision. So when I used to use the standard flow printer, I used to be able to say emboss, our Bionic logo on the socket, and the standard printer would just print it, with the logo on the side. But I have not tried that on the high flow system, because the high flow system, because it's not a fine print. It cannot do, fine print. It cannot do, I don't know if precision is the right word, but it cannot do intricate details on the socket yet that I'm aware of with everything I've played with. So it's certainly faster, but and the surface finish. When you do a standard flow, I mean, depending on what layer height you use for each layer, you can get the surface structure to be fairly smooth in FDM printing. Of course, you can get a much smoother finish with MJF and other technologies, but with FDM, you do have some some ridges, but they're very, very fine on the standard printer. But on the high flow, because I use waves mode and I use a 1 millimeter layer height, you can go up to a half millimeter layer height as well. The ridges on the surface of the socket are more visible, and you can feel those ridges as you move your hand over the surface of the socket. And some of the concerns that our practitioners raised initially was, well, it has all these ridges, so the surface, the inner surface of the socket is not perfectly smooth or flat like they're used to with the traditional fabrication. Will the patient tolerate it? And, we have been using that printer for about a year now, and regularly every day at multiple of our clinics, and we have not had any patient, of course, all of these patients have a gel liner on their residual limb as an interface between the socket and their limb, but we have not had any patient that complained that I can feel those ridges, through the gel liner. And if anything, patients have actually said, well, I feel like it's holding me a little bit better, because I think you increase the coefficient of friction when you have a little bit of that. I compare it to, what, the EMS socket technology, if you're familiar with that, where, you increase the surface area inside the socket that can grab onto the limb, and it increases the friction, reduces pistoning to some extent, and it works. We recently actually put a below the elbow patient on a skin fit socket on the high flow system, and we're like, this will be a good way to see if the patient can feel the ridges of of a socket in a skin fit. Of course, it wasn't weight bearing, but the patient has been using it with no complaints so far. So yes, very excited about that. I certainly haven't tried a skin fit with a weight bearing, low limb socket with the high flow with those ridges. We'll see where that takes us. The other thing to know is, because these high flow printers oftentimes will print in what we call a vase mode, where it's printing in a spiral. For people who are not familiar with 3D printing technology, standard flow printers print one layer, finish that layer, go to the next layer. But when you use a spiral mode, it's kind of continuously printing like a spring, and just bonding the layer to the layer underneath. What happens with that is, if you print something for a suction socket, there is a channel throughout the socket that spirals around, that's created. So there's going to be a little bit of an air leak through that over time. Now, of course, if you put a sleeve over the socket, you eliminate that issue. But if you're using a seal-in liner with a gasket, you're not going to have the perfect seal, because there's going to be a slow, constant leak through the channel that's created through that spiral vase mode printing.
Wow. So the texture. So what you're saying is that the texture from the high flow printing seems actually to be, very much a benefit. And then you just have. And I mean, that's pretty impressive with a skin fit for the arm thing. That's pretty wild. So
yes, yeah. One thing I have noticed is when we do use this, I kind of keep the fit kind of a half ply loose, just to have room for that friction, because the surface is not, the texture is there. When my practitioner tries the test socket and it fits perfect, and they say, well, can you print the flexible inner now, I usually make it maybe a half ply loose, just to have room for them to slide in with that friction.
Gotcha.
And I think it's interesting that the high-flow is working so well for you. Does it mean, but you do still have the regular printers, right? Are you also going to keep them, or are you going to only switch to... Yeah.
No, absolutely. We use the standard flow printer as well. So, with the high flow, because we print in base mode only right now with that, there are some technical limitations on what you can print as a base. So, if I have to print a socket that, I need, a rounded, inner surface, and I want to kind of build an adapter or something at the very end of the socket, a distal adapter inbuilt. Those things print better in a non-base mode on a standard printer because it can print different layers. In base mode, it's challenging to print some of those. So I certainly use a standard flow printer, especially if somebody says, "Well, I need a valve outlet on my socket, and I need kind of a shift plate printed along with the socket." Then I use the standard flow. We also recently bought one of the PVA med printers, so we have that one as well. And that's not a high flow, but it also does a decent job, and it kind of has its own software that allows you to slice it and kind of print things with some reinforcement. So I have the standard printer, I have the high flow printer, and I have the PVA matte printer. That it takes a 1.75 millimeter filament, but it's able to print 2.5 to 3 millimeter sockets in spiral mode with reinforcements at the distal end, and does a pretty good job with that.
Okay. And let's say I was like an orthotist, prosthetist, and wanted to get started with 3D printing. What would you recommend I do, or what would you recommend where do I get started?
Well, the first step I would say is understand. Talk to someone who has been using 3D printing at their practice. Ask them. Understand all the elements that go into incorporating 3D printing into your practice. Whether that is scanning. I mean, there are multiple ways how you can digitize your measurements, whether it's, with an iPad and a structure scanner, and within the structure scanner, there are multiple different apps that you can use. And now there are technologies where you can actually scan just using your phone camera. So there are a lot of these software capturing options out there. So first explore that. There's white light scanners, structure scanners, there's phone scanners. See what works. See how much it costs, how effective is that, how feasible is that for your practice, for the type of care you provide. So that's the first element, how to digitize it. The second is, how do you then do the clinical modifications to that raw scan? Whether that is reducing it by a certain percentage, or adding relief areas, adding pressure areas, kind of modifying what practitioners typically do on a plaster model to bring it to a shape that they want before they fit it on the patient. Again, there are multiple different softwares that are out there that allow you to do those clinical digital modifications. Explore those. See how easy or difficult that is. Kind of learn that process first, and then the third thing is, once you have, once you know, okay, this is how I can capture, this is how I can, digitally modify. The third aspect is, well, now I have this modified CAD model. How do I design a socket out of this digitally? And again, there are multiple applications, multiple softwares that allow you to do it. Mesh Mixer is one that I recommend to beginners because it is free. It is very user friendly. You can find a lot of YouTube videos on how you can design those sockets on Mesh Mixer as well. So explore those and see what clicks with you. And then the fourth thing is, okay, now I have designed the socket. Now how do I print this? So explore all your technologies. Explore, look at what FDM is able to do and not able to do. Look at the pros and cons of all of these options that are available. Look at MJF, look at SLS, look at all these technologies that are available, explore the pros and cons, explore the costs of all of these different systems, and then decide, okay, how do I want to incorporate this? Do I want to just incorporate maybe scanning right now and have somebody else print it for me and design it for me because I'm not quite there yet? Maybe that would be a good start, or maybe, hey, I want to scan and I want to modify, but I don't want to print right now. There are a lot of services available right now where, you could do certain parts of this digitization process yourself, and then you can outsource the other aspects until you reach a point where you feel that you can embrace that and you can do it yourself. So, yeah, I would encourage a practitioner who is kind of just new to digitization and 3D printing in ONP to first understand the process, understand all these different elements, explore what all it takes, explore the pros and cons, and then see, you don't have to jump into it 100% and do all of it at once. There's going to be a learning curve. Be prepared for it. I always tell people 3D printing is not a magic wand. You buy a printer and that's it. Tomorrow you're going to start printing everything digitally. It doesn't work that way. And, Brent will tell you the same thing. There is a learning curve. And so you have to be able to first understand the process, explore and know the pros and cons and the costs, and see, your comfort level and dip your toe a little bit into it and, to your comfort level. And, once you get a taste of it, there's no going back.
Yeah, definitely, dude. I think that's very sound advice. And I love the shout out to Mesh Mixer, which is like this kind of orphan software that's been going. I think Ryan Schmidt wrote it like a long time ago and has been going, and I still use it. And it's still amazing.
Absolutely.
And yeah, thank you so much for your good advice and sharing your experiences. I think it's really, really going to really help a lot of people. Thank you so much.
Thank you.
And Brent, thank you for being here as well.
Oh, this has been great. And man, if somebody can't take a little nugget away from this show, there's a problem. That's for sure.
Yeah, definitely. And thank you very much for listening. My name is Joris Peels. This is another episode of the Prosthetics and Orthotics podcast. And we really hope you enjoyed it. And really hope you come back for more. Have a great day.